So for question number 8, we are given this situation with a cylinder and a string that's attached to it. And basically, once we release the system, the stone falls at a speed of 3 meters per second after falling like about 4.5 meters. And it's asking us to find the mass of the cylinder. Some other information to know: the little stone that's attaching to the string is 3 kilograms, and the cylinder has a radius of 1 meter. Okay, so how to find the mass of this cylinder given the information that we know? Okay, so we're gonna start with F equals ma. We have 3g minus t, which is the tension, equals to ma. We solve for t, 3g minus ma, right, to find what t is. And the tension is actually going to produce a torque. So this, sorry about that. This tension here, this tension in the string is actually producing a torque, which we can call delta, right? So the torque is going to be equal times the moment of, I'm pretty sure this is the moment of inertia, times delta, right? And delta is going to be equal to, we know that delta is we know that acceleration is equal to delta times r. So the delta, solving for delta, is going to be a divided by r. So that's why we get that, the acceleration over the radius. And we have here the radius is going to be equal to tension, which is 3g minus ma, which we already solved for over here. We just transferred there. And then we also know that the change in y, the change in y is going to be 4.5 meters. That's how much it fell, and the velocity is this much, right? And basically this part over here, v squared, we get it from this equation here. V squared is equal to v squared plus 2a times the change in distance. This cancels out with the v squared, or it's not there really, and then we just have 2a, the change in y, which is the distance s, right? And then we end up getting, we solve for a, and we end up getting that it's 1 meters squared, 1 meter per second squared. Now we have the acceleration, right? Okay, so knowing that, we keep solving on. This is now that we have the acceleration, we can put it over there with the thing we had before. Now we just start plugging numbers of the numbers that we already have, right? We have, once you start plugging in numbers, we have your 30, 3 times 10, right? Minus the mass which we moved, and then once you basically start plugging everything in, you should get around the mass equal 54 kilograms.